Alright, hello class and welcome to the fifth section of our classes for CSC 321 Advanced Level Programming Language C++. Today we are going to talk on statements and flow control, okay? We are going to see how we work with statement in C++ and how we work with statement can be the if statements and what have you. Flow control can be the loops, constructs and their types, okay? A simple C++ statement is an individual instruction of a program. Example, variable declarations and expressions that end with semicolon. A program may repeat segments of code or take decisions and split. The statement may either be a simple C++ statement such as single instructions terminated with a semicolon or a compound statement. Okay? Let's look at this simple statement. We have appearing like this. Let me have a pen. That's okay, like this. All right, look at it. Here we have the begin. We have statement 1, statement 2, statement 3, each of them with an end of line. Then we have the end curly bracket here. Can you see that? Another way of representing something like this is using it in the same line. You have begin here, you have statement 1, statement 2, statement 3, each of them with the end of line semicolon. So the entire block is considered as a single statement composed of multiple sub-statements. A generic statement can either be a simple statement or a compound statement. Now, let's look at the syntax of the if statement. If is a condition statement. Now we are going to look at the single if statement, that when you are considering only one condition at a time. In that one, the general syntax is if, condition, then statement. Condition is the expression that is being evaluated if this condition is true. Statement is executed. If it is false, statement is not executed. It can be executed only, the statement will be executed only if this condition happens to be true. Otherwise, it will not be executed. So it doesn't have any other thing else. Look at the simple example that demonstrates this one. For example, you can have if x equal to 100, then see out x is 100. If x is not exactly 100, the statement x equal to 100 is ignored and nothing is printed. Okay? The statement shall be enclosed in braces, thus having beginning and end, forming a block. Look at this example. If x equal to 100, you can see the braces, the beginning of the if and the end of the if. In between the braces, you have your statement. You see, if this condition happens to be true, begin, see out, x is, the value of x is 100, then you should put in x is 100. Hope you get it. Okay. The next one is the if and else. Once we have seen how the if works, next one is the if and else. Selection statement with if can also specify what happens when the condition is not fulfilled. This is done by using the else to introduce an alternative statement, just like in the general form here. If condition, statement 1, else statement 2. Can you see that? Now, look at the example to demonstrate the if else. If x equal to 100, see out x is 100. Else see out x is not 100. You know, in the previous one, it's just a one-way if. If the condition is true, it executes it. Otherwise, it will not. But in this case, if the condition is true, do this thing. If it's not true, do this thing. Okay? Several if plus else structure can be concatenated for checking a range of values. Wow, look at it in a simple example here. Several if and else. We have if x greater than 0, see out x is positive, else if x is less than 0, see out x is negative, else see out x is 0. Can you see that? Wow. Then the next thing we are going to see, apart from the statement, apart from the if else, next one is the loops, or what they call iteration. A loop allows the execution of statement or group of statements multiple times. The general form of a loop statement in most of the programming language is in this format. Look at the diagram here, the flow chart here. You have your condition. If the condition is true, the conditional code will be evaluated. If the condition is false, the false condition will be evaluated. Let's look at the different kinds of loop statement that we work with them in C++. The most common one, and one of the most common one, is the while loop. The while loop simply repeats statement while the expression is true. If after any execution of the statement, expression is no longer true, the loop ends. The program continues right after the loop. The syntax is while in bracket expression statement. Let's have an example to demonstrate it. Look at it. Custom countdown using while. You can see we have the include IO stream using namespace std int main int n equal to 10. So look at the way the while loop start. While n greater than 0, this is our expression. This is the begin. This is the statement count n, comma, then the end is being decremented here. That's the end of the loop. Here this braces, then see out lift off. Once it finish with the loop, the next thing that follow, it will print this thing, lift off. Then move to the next line. Can you see that? So let's check this and see what really happens. In the first instance, our end is given to be 10. Can we see? So it will see out n. Of course, n is 10, so it will print 10, just like in this case. Okay. Then next one, it will print semicolon, comma. That's why you see 10 with comma here. Then it will decrement the value of n. That's 10 minus 1. So what remains is 9. So now it will check again. Is 9 greater than 0? Of course, 9 is greater than 0. Then it will print 9. That's the C out n. Then the comma, it will print the comma. Then it will decrement the value of 9. That's 9 minus 1, which is 8. That's why we are having 8 here. And it will continue in that fashion. When is it going to end? It's when your n is 1. Okay. The next thing, it will decrement the value of 1. That's 1 minus 1 is 0. Then in the condition, you will have 0 greater than 0. Which is 0 greater than 0, is false. Then it will go out of the while loop and print out lift off. That's why immediately after 1 comma, you see the lift off. Hope you get the concept. Okay. The next one after the while loop is the do while loop. It behaves like a while loop, except that the condition is evaluated after the execution of statement instead of before. That's the major difference. Guaranteeing at least one execution of statement even if condition is not fulfilled, because it is at the top. Okay, the statement is at the top, the condition comes at the end. This is the general syntax of the do while. Do statement while condition. Let's look at the example to demonstrate this. Alright, yes, you can see the first line is echo machine, then the second line include IO stream. Wow, here a string is included, a string header is included using namespace std int main. A string is the str is declared to be of data type string. You can see where the do loop start, do begin. So here is see out enter text. Inside the loop, user will be asked to enter a text. The next one is get line change str. So whatsoever the user type will be given as an input, or whatsoever the user type, it will be stored inside the str. Then it will print you enter whatsoever the user type. If, for example, enter text, you just type AK. Okay. Once you press enter, it will print you enter AK. Okay, that's what it means. And this thing will only end, the loop will only end when the string that you type is not equal to goodbye. As long as the string that you type is not equal to goodbye, it will be repeating this loop. But once you type goodbye, it will terminate the loop. I hope you get the logic. We have an example here to demonstrate it. Look at the first one, enter text. Okay, maybe the user here type hello. Then after pressing the return key, it will just display you enter hello. Okay, then it will prompt again, enter text. Then the user then type who's there. Then after pressing the return key, it will just print you enter who's there. enter text. So this time user type goodbye, then it just print to enter goodbye, and you cannot see enter text again because that's the end of the loop. Hope you get the logic. Okay, let's move next. Next one is the for loop. The for loop is designed to iterate a number of times for initialization condition increase statement. Can you see that? That's the for loop. That's the general syntax for the for loop. For the increase can either be increase or decrease. Okay, increment or decrement. So let's look and see how it works in a program. Here is a countdown example using for loop, just like the one we have using the while loop. We have the same portion, the same width using for loop here. Look at the include IO stream using namespace std int main. Wow, this is where the loop for loop start. For the variable n is declared and initialized here. Int n equal to 10, n greater than 0, n minus minus, c out n, then comma. Once it's out of the loop, it print lift off. If you look at here, the first instance is an assignment, then this is the condition, this is the decrement. Okay, it will print the value of n as 10 here, then it will print comma, then the value will be decremented. 10 minus 1, that's going to be 9. Okay, is 9 greater than 0? Yes, 9 is greater than 0. Then it will do what is inside this loop. That's print 9 and comma. Then it will decrement the value of 9 to 8. Is 8 greater than 0? Yes, 8 is greater than 0. Then it will print 8, then comma. Okay, then decrement the value of 8 to 7. It continues in that fashion until it reaches 1. Okay, after printing 1, it will decrement the value of 1. That's 1 minus 1, you have 0. Then is 0 greater than 0? That one is no, it's false. Then to go out of the loop and print lift off. That's why after 1 comma, you see lift off. How we get the logic. Okay. The 3 fields in a for loop are optional. They can be left empty, but in all cases, the semicolon signs between them are required. For example, for semicolon n less than 10 semicolon is a loop without initialization or increase or equivalent to while loop. How we get it? The first one, the first part and the last part are all missing. Okay. Apart from this, you can have something like this: for semicolon n less than 10 semicolon plus plus n. It's a loop with increase but no initialization in this case. Maybe because the variable was already initialized before the loop. A loop with no condition is equivalent to a loop with true as condition. That is an infinite loop. One has to be very careful when he is writing a program using loop, okay, so that he cannot fall into the infinite loop. Okay. The for can make use of comma operator to separate multiple expressions. That's the beauty part of it. Using comma for a for loop to handle 2 counter variables, initialization and increasing. Look at this example. For n equal to 0, I equal to 100, n not equal to I, plus plus n, minus minus 1. You can see 2 different variables, 2 counter variables are used. They may not be the same, as we all know. For n equal to 0, I equal to 100. See, there are 2 different variables. And look at even the condition is based on the variables n not equal to I. Then this one will be incremented and this one will be decremented. Then whatsoever you want to type based on the condition should be typed within the braces. You get the logic? Then the next one is the break statement. The break statement leaves a loop even if the condition for its end is not fulfilled. It can be used to end an infinite loop or to force it to end before its natural end. For example, let's stop the countdown before its natural end. Look at it here. If you look at the program, we have int main for int n equal to 10, n greater than 0, n minus minus. It will be printing from 10 up to 1, then just like we did before. But here, because we are introducing break, you look at it, we're having a condition here. If n equal to 3, see out, countdown aborted, then break. So as long as it reaches 3, that's why in the output here, as long as it reaches 3, you can just print countdown about it, and all the remaining numbers are now skip. Okay, that's why you cannot see 2, you cannot see 1. Okay, why? It is because after 3 is break. Based on after the condition is break. Okay, if eventually the condition if n is equal to 7, so immediately after 7 you'll be having countdown about it, then 6, 5, 4, 3 will no longer be there. How you get the concept? Okay, apart from that one, we have what we call the continuous statement. Apart from the break, the continuous statement causes the program to skip the rest of the loop in the current iteration as if the end of the statement block had reached, causing it to jump to the start of the following iteration. For example, let's keep number 5 in our countdown. Look at it here. We having include IO string using namespace std int main for int n equal to 10, n greater than 0, n minus minus begin. Now we look at it. If n equal to 5, continue. Then see out n, then your semicolon will be printed. Then out of the loop, lift off. So now if you look at the output here, 10, 9, 8, 7, 6. But 5 is not longer here. You can see once it is 5, it will continue. It will skip 5 and continue to 4, 3, 2, 1. Unlike the previous one. If it is break, the remaining ones also will no longer be there. But if it is continue, it will just affect only the one under consideration. For example, now if n is equal to 6, it's only 6 that will be skipped. All the remaining ones will be there. We get the concept. Okay, and the next thing we are going to see is the goto statement. Goto allows to make an absolute jump to another destination point in the program. The destination point is defined by a label. The label is used as an argument for the goto statement. A label is made of valid identifier followed by a colon. Goto is a feature of low-level language used in C++. Okay, let's look at this example that demonstrates the goto lib example. We have the include IO string using namespace std int main int n equal to 10. Can you see that? Then my label, full colon, C out n, then it will print the semicolon again, and the comma, then n minus minus. If n greater than 0, go to. You can see where the goto is. We have my label here, then here we are going go to my label. So at this place, if you look at it critically, okay, right from here it will just print the value of 10. And at this junction, what is the value of 10? What's the value of n? Sorry, is 10. I've just said it. Okay, so it will just print 10 followed by the comma, just like this. Okay, then it will decrement the value of 10. Then from 10 now, n is 9. Then is 9 greater than 0? If the condition is true, that's when the goto will hold. If the condition is true. So if n is greater than 0, that's if 9 is greater than 0, then go to my level. Then to repeat this thing again. In that case, your n is 9. Then comma. It will print 9, then comma. Okay? Then it will decrement the value of 9. Now you are having 8. Is 8 greater than 0? Yes, 8 is greater than 0. Then it will go to level. Then it will print 8. Then it will print comma. Then it will decrement. It continues like that until it reaches 1. When you decrement the value of 1, you have 0. If 0 is 0 greater than 0, this one is no, then it will print lift off. That's why it's up here like this. Hope you get the logic. Next one, switch statement. The syntax of the switch statement is a bit peculiar. Its purpose is to check for value among number of possible constant expressions. It is something similar to concatenating if-else statement, but limited to constant expression. Yeah, in most cases, they look alike with the if-else statement. Look at the general flow of the switch statement. We have switch, this is where we have the expression, we have the braces begin, and of course, we must have its end counterpart. Then case constant 1, group of statement 1, then we break. Case constant 2, you have group of statement 2, then you break. Eventually, you have case constant 3, you should have group statement 3, then break. Up to default, then default group of statements. though it's optional. Let's look at the explanation on this switch statement. Okay, switch evaluate expression and checks if it's equivalent to constant 1. If it is, it executes the group of statements 1 until it finds the break statement. When it finds this break statement, the program jumps to the end of the entire switch statement as the closing brace. If the expression was not equal to constant 1, it is then checked against constant 2. If it is equal to this, it executes the group of statement 2 until a break is found. Finally, if the value of the expression did not match any of the previously specified constant, the program executes the default, that's label, if it exists, since it is optional. Okay, now look at these two examples. The one with switch example, the other one with the if else. Switch x, you have your begin case it is 1, this is what will happen, x is 1, break. Case 2, stay out x is 2, then break. Default value of x is unknown. Now look at the it else equivalent. If x equal to 1, see out x is 1, else if x is equal to 2, see out x is 2, else see out value of x is unknown. Basically, if you look at these two examples, they end up producing the same thing but in different form. While this use switch, this one use if else. Hope you get the logic. Okay. Another way of representing this switch, something like this. Switch x, we have here begin case 1, case 2, case 3. See out. Can you see that? X is 1, 2, or 3. This one printed as output. Then break. Then default, see out. X is not 1, 2, nor 3. You see that? With this, we come to the end of today's class. Thank you